axes, and this is a real and imaginary axis. And we have on here the poles and the different things. We have, you're asking 15. There it is. Oh, there's no double poles. I thought you said there were double poles. No. What does that produce? You know, put by itself. Sinusoidal. Is it decaying in any way?
No.
So the blue signal, just let's add them up. The blue signal is just some non-decaying sinusoidal signal in time. Good. What's the, there's a pole at the origin. Step. Does it, do we know if the step is up or down?
No.
Just like this, we know the frequency, but we know nothing about its size, nor its phase angle. But this could be a step up, it could be a step down, or anything like that. But there's a step involved because of that. What is this pole right here?
Exponential.
Yeah, so we've got an exponential. Again, we don't know if it's up or down. My guess is normally, if this one's up, this one's down like this. So together they make what? Usually it's something like that. Now, how does this add to this? When you add them, what do you get?
Sinusoid around that.
Yeah, so you get some sort of a sinusoid around that. That's like this. So we're looking for something like that. The truth is, in these, often it's best to look at this and figure out what the poles have to be, because that's actually a little easier. But is there anything here that looks even remotely like that?
Yeah, that one.
That one right there does, doesn't it?
So, sine will only have a pole in decay if it's imaginary and not on the origin.
Yeah, I know what you mean, but you didn't say it right. The imaginary is there, yeah. But if it's on that imaginary axis, then it will not decay. If it is to the right side of the imaginary axis, it does what?
Explodes.
Yeah, exponentially. It's on the left side of the imaginary axis, what does it do? In what form?
Exponentially.
Curved, exponentially. If it's on the axis, it does what?
Just sinusoid.
What if it's double? Double here, double there.
Then linearly increase.
Explodes.
Linearly
Literally.
Linear increase. There is no linear decrease.
Double means line. Isn't there one where it is? That's the only thing we got. Like a downward ramp? Or something kind of like that.
Okay, the ramp, when you get a ramp, that ramp could be up or down like that. But that doesn't talk about the envelope of the sine wave or the amplitude of the sine wave. You don't get one with the sine wave linearly decreases in amplitude. Because what I took with you to mean is this, where this is linear, not curved. Oh, no such.
Yeah.
Yeah.
You have that.
The only way it'll be an exponential decay. Anything? Okay. Is there any, find me what have we not done? Let's see. We have done some stuff between signals and poles, right?
I haven't done the one where they give you the output and an input and ask you to find a transfer function.
Okay, we haven't done that. Let's do one. You got one in mind?
Really cares, anybody have one?
Spring of 16.
Spring of 16.
Which is it too late to move the test?
Which problem's that?
It's problem 5.
Problem 5, spring of 16. This is kind of same as we do with systems and stuff, only working backwards. Instead of doing partial fraction expansion, we have to do some combination stuff. Spring 16, probably 5.
I kind of zoned out.
What's
I've
that?
read since 12:30 a.m.
What's that, Marissa?
I was just gabbering.
With a wacky sleep schedule.
I do, I work graveyards, so.
Oh my goodness.
My
Can you get a
sleep-
day or two off?
Huh?
Can you, so you can be fresh for Wednesday?
Oh, no, I didn't work last night. My sleep schedule's just all messed up because of working graveyard.
You're just constantly walking around with a case of jet lag.
Yeah.
Yeah.
And so like coffee is my friend.
For a while. It's a temporary buddy.
Then I get more.
I see.
I hang out with coffee every 4 hours.
Oh, man. X of t is equal to 3 e to the minus 9t u of t. Good. And y of t is equal to 1 plus 4 e to the minus 6t plus e to the minus 9t. That begins with the output. The question is, what is h of s? Hi. Hi. How's this guy doing to me? He's gonna kill me.
Y of t divided by x of t.
Right. No.
No.
You gotta do y, x.
Y of
Y of s divided by
y of s divided by x of s.
Yeah.
All right, Jake. You asked the question.
I didn't
Wanna
ask
get
the
up?
question, I just told you one you hadn't done yet.
Oh, okay. Does anyone else want to do this? To learn more?
I'm very comfortable in this question, so I'd rather someone else.
Well, what's the point of doing what you're comfortable with? That's what I do.
I don't know.
Anybody want it?
Go for it, John. Yeah, go for it, Jake. What do you do?
Go for it.
So what's step 1 right off the bat?
Convert to the S domain.
Convert them to the x domain, S domain. Blue and green are right there. Thank you. It's time I just go with this.
Or is it got those ones because I found that parents have our level.
Have they got it? Is which one?
That's.
Agreement, disagreement? We good? Good.
Sound a little sleep deprived.
Yeah, you're gonna have to be careful. And when I'm tired, like the car travels me to sleep. You just gotta keep talking to me while I'm trying to.
Somebody else is driving, right?
Do you ever call you an Uber or something?
No, I'm good.
We did regular train station.
You need to fall asleep in my office.
No, I'm good.
I'm scared.
My car is kinda ghetto. I'm going.
So it keeps you awake because of the muffler. Everything has a purpose, I suppose. Good that you
Sleep.
Are we in agreement?
Yeah.
Okay, what's he gotta do with that y of s?
Common denominator.
Yeah, I couldn't
Yeah,
possibly.
so he's gotta do the opposite of partial fraction expansion.
Did you put it together, Bruce? Y over x?
No, I wouldn't. I would do this for. So what I'm really doing here is I'm doing the exact opposite of what you've done with the partial fraction expansion. I've done the exact opposite. Here's a signal, here is a transfer function, here let's find the output signal. Here we're giving you an input and output. Does that though show you that you could maybe do something like this in the lab and figure out what a system's transfer function is? I mean, you wouldn't put in anything that complicated. What do you normally put into a system when you're trying to figure out the transfer function?
delta function.
And
Well,
plus,
if you could make one, yeah.
Or step function.
Step, yeah. Delta, even when you're trying to make a pseudo delta, is easy to go overboard. What do we think, gentlemen and ladies? Is he did it right?
Now combine it.
Yeah.
Well, I think he's right. I think he's on the mark.
What multiply cancel? Yeah, so we're gonna multiply it.
Go for another color, red over here.
Oh, don't.
Combine them,
don't
make it nice and
make it
clean.
all- Don't do that?
What?
go red.
No, like, don't make it like an S.
Don't go red, is that what you're saying?
No.
We're good.
No.
There was some other discussion going on back
So,
here.
no, use red, we're talking about something different.
Okay.
Oh, stop. What we were gonna do first, or we were suggesting you do first, is combine those terms in the numerator there as much as you can.
Oh.
Clean that numerator up.
Okay.
That's what we're suggesting you do in red, so you went from the green to the red.
Oh,
That's the
I
next
wasn't
thing.
gonna do that.
And you can do the red
I
right
erased all
above
that for
it.
nothing, G.
Okay, so square
You do that right?
Yeah.
With me.
Oh, is this the no calculator part? Oh, wait, that's not the no calculator, there's no no calculator part. It's a no paper part.
You're making.
Equation sheet.
So what do we got there?
We'll just
Square root of 6s and 36s, 4 times 9, yep. Yep, I agree. Anybody want it? So this stuff, you don't try to rush too much. Take your time and do it, it still doesn't take that much time.
Yeah, but we only got 50 minutes for this test.
That's right.
They seem pretty beefy, or do you have a lot of trouble with people finishing them? Like, what do you
Well,
recommend if?
we haven't in the past, but then usually we could overrun a bit, and this time we really can't much. You did get my email saying if you're there a little early, the TA will hand it out early, right?
Oh, you did? Cool.
Okay.
So the TA will be there earlier because I have the other class in front of it.
How
She'll
early
be
is
there
it
at
gonna be
10:30.
How early are you gonna be there?
10:30.
Okay.
10:30?
There's class before that?
No, there isn't, I don't think, but there's a
No,
class
there-
after.
There's not one before.
Does anyone have a
Yeah,
class
there-
beforehand?
I went there, I
Got a
think,
lab beforehand.
10.
When does it usually end?
There's nobody in
No,
there.
'cause
15
that
minutes
room
before class.
upstairs is freezing.
Ah, so you're complaining about my running lab running 3 hours.
I didn't think that
The
I'd
other lab
sit
runs
down
3 hours
somewhere
too,
else
or
that
do you
was
show up?
very smart.
No, it runs, so
So I
it's a
took
project
class.
and it usually takes like 3 lab periods of 3-hour blocks.
Oh, are
the
you
last-
that numerical?
Damn.
method?
No,
I'm gonna be the meanest person.
Well, so the last one doesn't take you the full 3 hours, but you don't know that going in, so you take 3
Ah,
hours,
so you
3
take
hours,
3
and then you
hours,
might be at 1 hour.
Okay, well, 3,700 is just definitely way worse than any class you've ever taught, so you're not.
Not telling that, test hard.
Oh, his tests are like, the solutions are easy, but for some reason it just trips you up. I don't know how he does it. Just makes these problems there.
Gotta think this stuff through.
Did
Okay,
you flip-
only, all right, back up. So he's got that numerator of this thing
Awesome.
down to 6s plus 57s plus 54. We all agree with that?
Right.
Put that on.
Looks good to me.
Except it should be Y or X.
Yeah, just,
Right,
just
he's
put
saying
that
that
in
part's wrong.
parentheses
Yeah.
and put it to the negative one.
And now he's got this, so that's it. Take the top 3 over s plus 9 away.
Yeah.
And the reason I'm telling you to do that, as you'll see in just a second. And notice he hasn't multiplied out the bottom, which is a good idea, because there's gonna be some cancellation there.
So you just walk through this.
Yeah, give
Just
it.
to take that top off. Okay, rather than set it up as a division, when you're dividing in fractions, what do you do? Invert and multiply. So what has to be divided by what to get the h of s? Is it y divided by x, or is it x divided by y?
Y divided by X.
So you had it kind of screwed up anyway. So take that, no, yeah, there, that's fine, that's fine. Just too much to erase the whole thing. So what am I gonna multiply that by?
X plus 9 over 3.
Yeah, and immediately do cancel, that's good. Some of the output comes from the input.
Probably do 2s squared plus.
So look at that, it could just divide by 9, is it? Essentially all that's left.
Thank you.
Divide by 3.
Yeah, you know.
Okay, divided the top by 3.
It doesn't matter, what he's doing is fine.
Yeah,
What he's doing is fine.
Sorry.
If he left it in that way, that would be fine. I would be okay with that.
Is this good enough for the
That's
final
good.
answer?
Yeah, it's
I
good.
mean, I don't know if we're take it.
And then find the poles of the system.
Okay, the next, yeah, what are the poles of the system?
0, -6.
Yeah.
Good. Could you have figured that out without doing all this work?
Yes.
Probably, I could just look at the first ones.
Yeah, what are the poles in the input?
9.
9. What are the poles in the output?
-6, 9.
Yeah, and 9 comes from the input, so what are the only ones that don't come from the input? The 6, yeah, and the S. So we know what the system poles are. So one at the origin and one at 6, -6. So sure enough, that's what that shows. All right, next thing, is the system DIBO stable?
No.
Can you tell that without knowing what the poles are?
Yeah.
Why? Y of t, I'm getting a steady state output without putting any steady state input in. That's a bad sign. That means the system has a pole on the chain axis. That's the reason why you might be asked that reason too.
Because you have, so you know for the system, it can't have any poles.
Oh, on the, okay, yeah, on the access.
Right.
So it's not
And
behind
it has,
the table.
and it has one of the poles, so.
Very good.
I get it. That,
Zach, just put that sucker right out there.
So your test, you can, most likely you're gonna be able to do the problems pretty easy, but you can make it pretty complicated if you wanted to.
That's what people do. Make it pretty complicated, just like the H of 0 up there.